So 33 degrees C, 1 atm, 30% relative humidity. What is the humidity ratio? Can you find it on your chart? Yes, sir. D. Let's see if we have some concurrence. Let's let everybody find it. It's B? Is B? All right, it's B. It's a little tricky on those digits, isn't it? Thank you very much. Let's go to the next one. Thank you for participating. Now you can't participate. The specific volume at that condition. D. All right. Thumbs up if you agree. Agree? Good? Very good. Excellent. All right, let's press on. Same conditions, 33, 1 atm, 30% relative humidity. What is the wet bulb temperature? We have a B. I got 3, 4, 5 thumbs up, 6 thumbs up, 7, thank you very much. 8, yeah, hey, you're thumbing up yourself. All right, dew point temperature for the same condition. We have B is our dew point temperature. Thumbs up, thumbs up, thumbs up, thumbs up, thumbs up, thumbs up, thumbs up. Excellent. Very good. Thank you. So you're done. Dry bulb temperature is... You're ready to answer this one. Your hand was up fast. Don't overlook the obvious. So, yeah, right here. What's that giving you? 33 degrees C. They're telling you the dry bulb temperature. All right, very good. You're done for the day here. 33 degrees C, 1 atm, 30% relative humidity. It's flowing at 0.47 meter cube per second over a cooling coil. So it's approaching the cooling coil at that volumetric flow rate. What is the dry air mass flow rate? And you may need a calculator. So what is my mass flow rate of the dry air? Hey, didn't we want rho of the dry air times our volumetric flow rate? But this chart gives me the reciprocal, doesn't it? So the specific volume of the dry air times the volumetric flow rate. So we said the volumetric flow rate is 0.47 meter cube per second. Let me write it like this. Meter cube per second. What was our V, specific volume? 0.88? Yes. That was meter cube per kilogram of dry air. Not kilogram of moist air, only kilogram of dry air. And then I have this pesky 60 seconds is 1 minute because they want the answer in kilogram of dry air per minute. Who's gonna, yes sir? A. Let's see how many people concur. Concur. Very good. All right, now you're out too, thank you. What is the water vapor mass flow rate? So we have 32 kilograms of dry air per minute going toward that coil. How many kilograms of water vapor going toward that coil? What is the product of omega 1 times m dot dry air? Wouldn't this have units of kilogram of vapor per kilogram of dry air? Do you multiply that with the units of kilogram of dry air per minute? And this cancels. And you're left with kilograms of vapor flowing. Yes, sir. D. Okay. What was your omega for this problem? 0.0095. Okay. And then you multiply that. We already showed the units. Times the 32. Looks good, right? Okay, very good. All right. Oh, hey, same dry bulb, same total pressure, same humidity, same volumetric flow rate. It exits the coil at 15 degrees C. Okay. Is 15 degrees C less than the dew point temperature of the inlet air? Yes. Okay. You're going to say B. We got two B's. BB? Did you go B? You went B. You want to change your A? All right. Okay. So what is the dew point temperature for that inlet air? I think we calculated it, didn't we?
13, right?
I thought we calculated, was it back here, 13? Yeah, 13. So anyway, it's close. It's close. All right. The exit humidity ratio is, so if it comes in and goes out like that, do you think we're going to get any liquid? LIQ? No liquid. I mean, you could, even because the air that's really close to the metal surface of the coil actually feels a lower temperature than the air that sort of scoots through in the middle between the blades of the coil, the fins of the coil. That's another topic for another day. We're just doing a very simple analysis. No liquid forms and drops off the coil. So what is the omega 2? The same as 1. And what did we say omega 1 was?
0.0094.
This one?
Yeah.
Yeah, okay. All right, what is the exit relative humidity? So what happened on our psychrometric chart, we're over here and we just sort of cooled it. We didn't get all the way to 13, we went to 15 and we stopped. And we have to pick up the relative humidity. How high? 90%. E. Continue on. Now it exits still at 15, right? The inlet moist air enthalpy is, so what's H1? Yes, sir. We have a vote for A. Now you thumbs up A. See, he's chomping at the bit, ready to move us forward. Were you going to go with A? Yes, sir. D? Okay, we have 2 votes and 2 votes. This is the inlet, right? Not the exit. So basically on our psychrometric chart, we find the inlet, and then we have to kind of go back up and then read off that enthalpy. So I need a few more people to vote. A or D, or another answer if you like. Do you like D? He likes D. We're going down in number. Is it D?
Yes.
It is. Very good. What is now the exit? So we come over here. Remember 90% relative humidity. What is my exit enthalpy? Yes, sir. A. Exit is 39. I think you were giving me the answer for the exit last time. Is that what you gave me? Yeah, that's what you did. So now, what is the cooling load on the coil? So you have this coil, and you're basically doing like this. What is Q dot load on that coil that really comes out of the airstream, the moist air stream, with no condensation? Isn't that just going to be Q dot load on the coil equal to the mass flow rate of the dry air times the enthalpy coming in, which is 57, minus the mixture enthalpy going out, which is 39. So we have 57 minus 39. What are the units? Kilojoule per kilogram of dry air. That's why we like the mass flow rate of dry air. And I forgot our mass flow rate of dry air we calculated to be previous problem. What was our mass flow rate of dry air? 32 kilograms of dry air per minute, right? So let's jump back over here. This is 32 kilograms of dry air per minute. So the kilograms of dry air go kilojoules per minute, but they want it in watts. Oh, that pesky 60 again, right? So 60 seconds is a minute, and then we get rid of the the minutes. And a kilojoule per second is a kilowatt. A. Thumbs up. 1 thumbs up. 2, 3, 4, 5, 6, 7, 8. Good. There you go. See, we can do energy calculations. Finish with the psychrometric chart. So the moist air, blah, 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 blah. This what? Over the cooling coil, exits at 15 determined. Hey, we just did this, didn't we? Aren't these our answers? The mass flow rate of dry air. The condensate, nothing. No condensate. Didn't get it cold enough. And then the cooling rate. All right. Well, what happens if it comes out a little colder? 12 is a little colder, isn't it? And it's going to come out often. It never really comes out 100% relative humidity, but it's really close. So we picked 95% relative humidity. So what happens on our chart is here, and then instead of going all the way over, it actually exits something like there. So there is a change. You have omega 1 here, and you have a lower value of omega 2. Humidity ratio is lower. Some liquid condensates going out. So you can ask the same type of questions. What is the volumetric flow rate of air entering the coil? 130, no problem. What is the condensate flow rate? 1 kilogram per minute. And then what is that rate of heat transfer to the coil? 75. We just did that by hand. You can do it by chart.